Hello guys, in our previous tutorial we learned how to make a symbol for an electronic component and we took the example of the motor driver Alto 3D. In today's tutorial we'll focus on making a package and then integrating the symbol and package into a device. Now we create device so that when we design our PCB, the schematics, we can directly grab that particular component from the EAGLE library. So let's learn how to make the package first. So let's go to EAGLE, and I have already created a symbol for LM324. So let's start with that. So guys, this is the symbol for LM324, and now we learn how to make the package for this particular IC and then the device. So let's start. We need to refer the data sheet of this particular IC so that we can come to know that what kind of packages are available for this IC. So let's open the data sheet. Now in this data sheet of LM324, which is a quad operational amplifier, you see under description section they have described that two packages are available. One is the power dip package and another is the SMD package. So you can make the footprint for any of them. So let's make for the SMD package. So what you do first, you go to package and then press add package and then give it a name. Now firstly you try to check the inbuilt library of EAGLE and see if the package which is mentioned is already available or not. Let's press import. In this dialog box, search for that particular package using relevant keywords. So let's search it. So now EAGLE provides us some inbuilt packages in SOP 14. So just have a preview. And we can select one. For example, this one. So now this is the package for SOP 14 that we have taken from the inbuilt library of EAGLE, and here this one signifies that the numbering of pins will be started from here and it will be ordered in this manner. Now you can even change this name and value thing. So let's do it. And here you can simply change it and just write it as LM324 for better understanding, because when you make a schematic at that time these labels are very helpful when you basically want to recognize your symbol or your particular device. So here we are done very easily, but there are cases when you do not have the same footprint available in EAGLE library. In that case, you need to create your own footprint. So now we'll learn how to create our own footprint. For creating your own custom footprint, what you do first, go and save the name of the footprint first. So add package and just add the name. So when you create your own custom footprints, you need to be very cautious about the mechanical size and constraints of the pad and size of that particular IC. So for that particular purpose, let's open the datasheet once again. So in the mechanical dimension section, they have provided all the mechanical constraints and dimensions for both the packages. So let's see for SOP 14, and you can see here that they have defined the pad size, which is 1.70 cross 0.65, and the distance between the centers of two consecutive pads is 1.27, and these dimensions are in mm. So now we need to keep these dimensions in our mind when we design our own footprint. So let's move on to that part. Now just make a note of all the dimensions of the pad size as well as the package, so that when you create your design or footprint in EAGLE, it becomes easy for you to cross refer. So now let's go to EAGLE. So now go to pad option and just place it on the screen. You can right click and orient it. So now guys, in order to position this pad on the grid, there are two methods. One, you go and right click on this pad, and in properties tab, what you do, you go in position option and set the position of this particular pad and as well as its distance between the consecutive pad. Now this method, what I personally feel for beginners, it is a little difficult to feel comfortable with the coordinate adjustment of these pads on the grid. So it's basically easy. You simply go and adjust the grid size as per your requirement, but some people might find it comfortable to set the position using coordinate system. So anyhow, how you feel comfortable, you should go by that method, but I personally prefer setting the grid size. So go to grid, and then now in size, what I recommend you is that in our data sheet we have seen that between two consecutive pads the distance is 1.27 mm. So let us set the grid size as 1.27 mm so that it becomes easy for us to place the two consecutive pads. So now when you click on this pad, now you need to adjust the dimensions of this pad as well. Now let's right click on this pad and in properties adjust the dimensions. So now I think from the data sheet, let's see what the dimensions were. So it was 1.7 cross 0.65. So let's hit so now let's press OK. So similarly we have to change for the other pad also. So now the distance between two of these consecutive pads should be 1.27. So let's position it here. And now similarly we have 14 pins, so you need to place the 14 pins, 7 on one side and 7 on another side. So let's do that. Now we are done making one row of this footprint, and in order to make another row we need to ensure that what is the center to center distance between these two rows. So let's refer the data sheet for that. So here you can see that the distance between the center of one row to another is 5.6, and we need to make it there. So now let's go there. Now what you do, before you make another row, you basically move this row to the origin, because origin is the one place that always remains static on this grid, and you can always refer other components with respect to origin. So now what you do, you go and adjust the grid size as 5.6 because that is the distance we require between the two rows. So let's press it OK. Now let's just copy this. Now you can see that how well the rows are adjusted at a distance of 5.6 between them. So this is the benefit of adjusting the grid size and aligning the components on this particular grid. Let's make the outline for the component for the silk screen layer. Now for that purpose you need to again adjust the grid size. Now it's always recommended that if the distance between two grid lines is small, then you can make much more detailed outline and descriptive features of your component. Now in our case the distance between this row centers is 5.6, so I'll take the grid size as a factor of that distance so that we can align these pads symmetrically around that component outline. Now let me set it to 0.8. Now go to this line option, and then here select the layer, so which is T-place layer, and now you can simply start making your outline. ensure the proper orientation of the IC so as to match the designated pads, we need to make some identification like from where the pad 1 is placed. So let's select line and then let's make the outline a little more informative. So now guys, we have made our own customized footprint. You can always add extra information, like you can simply name this footprint and place it here. Now even if you want to adjust the size of this text, that you can very well do. So just right click on this plus symbol and just adjust the size if you want to adjust. So in this way, our footprint is created, and now we have to make the device. So let's try making a device of this IC. Once you are done saving your package, let's go to the library and create the device. Now here you need to add the symbol, so just add the symbol. Then the package. Now here two packages are available, and I'll just select the custom package that we created, another one. We took it from the EAGLE library. So let's select one and just proceed. Now here in this dialog box, basically you have three sections. One is the pin, so basically it describes the various pins, and then the pad section describes the pad. So now in connection we have to connect the pin to its corresponding pad. Now for that we need to refer the data sheet. So let's open the data sheet. Now in this block diagram you see that the pin output 1 is connected to the pad 1. So similarly you need to make a note of all the pins and connect them in the same manner on the PCB designing on EAGLE. So now as we saw, output 1 is connected to pin number 1. So now let's connect it, and then input 1 inverted was connected to the pin number 2. So connect this one, and then input 1 plus will be connected to pin number 3. So I think we have by mistake connected input 2, so just disconnect it and then select the input 1 again. So in the same way, depending on the pin position in that block diagram and the corresponding pad to that, you have to connect the pins. So now let's do that for all the other pins. Now once your connections are made, you can simply press OK and just save them. Now let's go to library and see if our device is created. So here we get a device LM324. So in our next tutorial, we'll try to learn how to make a schematic of a line follower, and we'll use such devices in that. So till then, stay in touch, keep watching, and do subscribe my channel and just give your valuable feedback. So goodbye.